So let's talk a little bit about the assignment over here, in which we would use something that we already worked on. If you remember the bouncing ball, the way back when we talked the first time about animation. Where is that? Let's see, that was in the first semester, somewhere in here. I think it was animations right here. And yeah, this one, definitely. So we go over here and we look at the website. I'm giving you something to start with, as usual. And then we did an activity based on that. So we're going to do something similar now too. Let me close this, we delete it, and let's go back to what we have to work on. I'm giving you step-by-step instructions on what to do. First of all, you need to download the BouncingBall project. And keep in mind that when that's downloaded and you put it in your folder, make sure that it doesn't go inside a project. So if I was going to look for all my stuff over here, it would be, let's take a look. What's my program right here? So I noticed that some of you have a project that has a purple image over here, a purple icon. And that's because you put the project inside another project. It's like nested project. So make sure that that's not the case. My projects are all separated, right? So I have a folder for all my animations, let's say now. And then I have a whole bunch of things by themselves. Here's the bouncing ball. This is what it should look like. Right here is this over here. And there's only one package. And then the next assignment is going to be collisions. And again, there's only one package. If you have a package within a package, that's bad. Or if you have a folder within a package, then that means that you have to drag it out. So that's to make sure that you don't run into that little situation, which is not a pretty situation by any means. So download this in a folder by itself, meaning like the unit 4 folder, let's say, right? I created another folder called animations because I like to organize my programs, because obviously I have lots of programs. So let's take a look at what you had the first time around. The first time around, you had the bouncing ball. And in the bouncing ball, you were given, right out of the text website, some information. Here is the position, velocity, and the radius of the ball. So these are what they call them, what we call them then, initial values, because this is a bouncing ball, right? And then we have that the while loop that continuously move the ball or keeps on going until you close that bouncing ball animation, the window. And here's all the instructions that you should be able to remember. And if you don't remember, just go back and look at it. But the idea in general was that every time the ball was close to the to one of the walls, because remember the scale over here goes from -1 to +1. So the origin, the center of the Cartesian plane, is right in the center of this square window, right? So if we get close to the ball position plus the velocity, that is going to be taken is greater than 1, that means it's all the way, what wall are we looking at over here? Is it right wall, left wall, top wall, or bottom wall? So if we're looking at this one over here, since it's on the X axis, well, the X should give you an indication of that. That means that it's actually looking at the right wall. Really? Just the right wall? Well, that's not entirely true because it's using the absolute value. So if it wasn't using the absolute value and you say greater than 1, then definitely it will be the right wall. And then you have to have another one just like this, in which is less than -1, and that will be the left wall. And you can do this, think of it the same for the top and the bottom. So this absolute value eliminates two extra lines of code. So all it's doing is when it gets to that particular value of the X coordinate, it's going to bounce back, meaning the velocity now is going to be changing in the opposite direction. And instead of incrementing, and remember the idea of the flipboard, right? The flipboard is that we're creating an illusion, nothing more than that. And so to be able to really appreciate that illusion, we see that every individual picture, in our case frame, it has the previous location or action that was taken, or drawing, whatever you want to call it. And then in addition, the next step to it that follows that. And so we have to wipe clean the frame. And we do that by using that the background. You can change the color, and that's what was part of the activities. If you remember, we did a whole bunch of little things that you made it different, fun. This one is kind of boring because it's gray, and I think the ball is black, right? By default, anything will be black here. This also. So the position keeps on changing. We want to clear the background, erase what we already had before, so we don't have that shadow. Remember we did that too? When we comment this out, you will leave behind the trail of what it was drawn earlier. And then once we actually clear the background, we redraw the ball, but at a new position, the position that changed because of the X and the Y, which is the velocity on X and the velocity on Y. And at that point, we talk about, how you get the coordinates for the center of the ball, which you need an X and a Y coordinate. Then we did the show, and we had to pause it, otherwise we wouldn't be able to actually, it will go either too fast, which is the default speed. So we needed to actually pause it so we can see it that is more appealing to the eye. You can, of course, increase the velocity or not. So what we want to do to turn this into object-oriented is we want to separate, and let's take a look over here. We want to separate the instance fields that define the ball and the methods that act on the ball, or that the ball has this type of, action. You can look at it either way. So we look at instance fields as attributes and methods as actions or verbs, behaviors, right? So we need to make that change. You need to take all of this, which is one program, into two programs. One that declares creates that blueprint, the factory, a template, and what the author calls it, a category or type of data type that defines what a ball is. And not just what it is, what it can do or what it can be done to it. And then you have over here the driver. The driver, just like we did before, in the two previous assignments, we have to create objects of the ADT, the abstract data type or class, and then we use that object to call in the methods. Those are the methods that actually gave the ball the ability to have actions, move in this case, because that's all it's doing, is moving and bouncing off the wall. So let's take a look over here at what I'm giving you. What I want you to do, let me rephrase that. What I want you to do, you won't see this when you get it next, because it was going to be a different, I was going to use this as actually the next assignment. And I realized that we were jumping too much from what we were doing before, which was the in the bank account, to the collision type of detection. So I thought it was more important that you can actually do the what it's called coupling of the bouncing ball, because bouncing ball right now is one big chunk. We're going to separate them. So you won't see this because you will be creating this. I'm going to give you though the actual. I'm going to give you something similar to that, but it's not going to have these two things that I'm going to show you how to work on. You will have to actually do the typing. Okay, so let's take a look over here. Let's start from here. This is what I decide or design what the ball ADT will look like. And remember, ADT is an abstract data type. Abstract because we call it abstract because this is pretty much an abstraction of what a ball is. We eliminated a lot of details of a ball, and we just focus on exactly what we need to have this animation. So what does a ball have as attributes? Here's the attributes right here. And we recognize the attributes are pretty much the instance fields, and that's because they are outside any method. If it's inside the method, it becomes local, and you won't be able to access from anywhere else. So this right here is accessible everywhere. And I'm going to use the word global very lightly because it's not a technical word, because Java doesn't have global keyword. There are other keywords that makes them global, but more global in terms of what is accessible anywhere in the class. So what would be the attributes or the instance fields of a ball? Well, I need to know the position, the X and Y coordinates of that ball. I also need to know the speed, which is moving. And in this case, we're going to call it more than speed. If you take in any physics, you know that velocity means that it's a vector in which it also gives you not just the speed, which is the absolute value of the movement, but also the direction. And we need to think about velocity because we know that the direction is going to be changing when it does the bouncing. And of course, I need more than just the position of the ball. I also need the radius. I need to know what the size of this ball is. It's made final, so you make sure that it doesn't, never change the radius because the radius should remain the same. I mean, there are other things you can do with this, obviously. I can imagine a million things that I could do with a ball in terms of simulation, in terms of the radius, and in terms of a lot of other things. But we're going to keep it to the minimum. And that's another reason why we call it abstraction. So here's the constructor. My constructor is going to, it's a default constructor, and it's going to initialize the values for each of these instance fields, attributes of the ball. Obviously, you can tell me where this starts. Where is the ball created? I'll put that question in there. So when you actually get to open this particular, actually let's put it there now. I usually make changes to the lesson as I go, and that's the beauty of teaching as opposed to recording a lecture. Let's put it here. Three, which is questions. Okay, so here is the ball. It is created. Question number one. So what is happening over here? Well, what is this? What are these two lines over here? What's Vx? What's happening at Vx and Vy in the constructor? That's another good question. What happens to Vx and Vy in the constructor? Try to fix this. Next. It looks to me that the first time around, the radius has a very specific value that is not going to change after that. And you can see that the radius of the ball is going to be between 0.025 and 0.75. It sounds like it's small, right? But if you consider the fact that the scale is the default scale, which is between -1 and 1, then that ball is not that small. It's actually pretty good. Next is all the behaviors. The behaviors of the ball. The ball can bounce of a vertical wall or a horizontal wall. Every time it does that, it's going to change the direction in which it's moving. A movement, like in the flipboard, all it means is a new location. And a new location is only calculated when you add or subtract a value to the X and Y coordinates. And that's exactly what we're doing over here. And then these two things are the ones that are going to make the changes on the direction. And that's what I call reflecting over here. Well, we need one more method, the method in which the actual ball is moving. And this is definitely coming from the original. Take a look at the similarity between the two then, and how well it can be coupled. Coupled because we have now a couple of classes or files handling something that it was all pretty much together in one place. So we make a nice distinction between what the object should look like and how they actually should behave. And the good thing about this is that you're going to see in the next assignment that you will be able to create multiple balls. Can you imagine having many balls if you are not using object-oriented design? Of course, some of you probably thinking about arrays, and you can use arrays. Actually, as a matter of fact, when we do colliding many balls, we're going to do that, and we're going to have arrays of balls. objects of balls. Let's see. So what's the difference between what we're doing over here and what we're doing in the original, which is non-object oriented, and here, which is object oriented? Well, number one, anything that's related to that condition that is met over here, which is bouncing, I turn it into two methods. And then any type of movement of the ball anywhere else is going to be, which is over here, update the position, is going to be part of move. And so I need now in the same location where I had the move, I had to determine when I'm going to be doing that code that bounces the ball. So instead of having it over here, I make it nice and clear with the method that I'm actually bouncing off a vertical wall and I'm bouncing off a horizontal wall. And that's why I have these two methods. The last method is actually a method related to drawing. So I don't really have to, it's actually a behavior that belongs to the fact that it's an animation, not because of the ball. So this is actually the coupling. I'm sorry, you taking apart the actual ball from this one big blob of code. So that means that now we need to find the driver, because an ADT cannot run. An ADT does not have a public static void main method. It only has a template of what a ball should look like and what a ball could do or could be done with it. So now we need to look at the driver. And the driver is right here. The driver now should be simple. It shouldn't have a lot of stuff because most of the stuff is already in the ADT. That's another beauty about object-oriented design. Bad things and good things. Well, we're looking at good things too. At this point, we're going to see the beauty of it. Before you probably were thinking, scratching your head, why do I have to write so much code? Well, in this case, we actually have two balls. Take a look. We have ball 1, ball 2. Here, I set up the scales for X and Y. Like I said before, we were going to be taking the default values, although I think the default values, I take it back, is 0 to 1, if I'm not mistaken. But here we're going to do it from -1 to 1 for both of them. Double buffering, so we don't have that flickering. So while something is being drawn into a pane, then there's already this render, and once the next frame or the pane is ready to go, it's being rendered, and so you don't have that flickering in which things are being displayed, rendered as it's being drawn, which is kind of ugly. So where's the while true that we have on the regular bouncing ball? It's right here. Here is they actually giving me a new blank page, drawing my new new drawings, my new graphics. This is the standard color, but we can give it different colors. And now we use the name of the objects right here. B1 is an object of type ball that can move. Here's the method. The method move allows me to do what the other one, the bouncing ball, was doing, the program. And it also has the ability to detect a wall. And if it detects a wall, it's going to call the method. We don't really have to call it over here because move is already checking that. And then all we do now is draw it, which is right here. It tells you, this method will tell you how to draw it. It's going to be a filled circle. It could be an image. It could be, I don't know, a square ball. It could be anything. And so, and then I do the typical thing that we do when we have an animation. and which it was part of the bouncing ball. So there's only a few things over here that is different from the original bouncing ball. It's true that we have to create objects, but then everything else is kind of hidden in there. That's another level of abstraction. The move itself, the method, is an abstraction of whatever is happening over here. So we did some hiding of the technical part, just like when you drive a car, you hide all the technical mumbo jumbo in there, all the shenanigans you don't really have to worry with. And so we created this abstraction that allows you to manipulate things in a very easy way. And obviously here is very easy. So when you do the next assignment, it's going to be, well, if I can create balls, as many balls as I want, can I create an array of balls? And then I am going to just let them move. Actually, that's the following assignment, not the next one. The next one is the one in which you detect collision, because now you have more than one ball. You should be able to detect each other. And when that happens, you want them to have a different type of behavior. It could be erratic, or it could be very physics related. It's up to you, but I'm going to make it more random so it doesn't make it too complicated. Okay, so for now, this is all we're going to do in this one. So you should be able to do this assignment without any problem, because I gave you pretty much the code. It wasn't written, but you can do that.